Well folks, this is one of these odd occasions that we're going to actually put down a cloth. It's a immaculate boxed Rotel 220. Well, not quite immaculate, but it is pretty good. Oh, I've left me a piece of paper. So we're on Sunday evening. Make a 10-minute start on this. It's very busy for me as a church organist, of course, at this time of year. So try and do these in dribs and drabs. Now, have I lost my pen? It's the kind of thing I'd do, isn't it? Yeah. RVC220. Still got the plastic on its rear label. He's also sent me another Rotel 220 with holes in the case as a donation, which is very kind because all these donations help run the repeater GB3GR, for which I'm solely responsible. So let's try it without opening it up. That's the ultrasonic cleaner just done another record side. We were connected with his power lead. We'll use our standard replacement mic. Plug in that. Switch the set on, which will test the internal speaker. For some reason I haven't turned the power supply on, which is at 13.8 volts. Yep. And we'll pop that on channel 20, just like that. Plug in the test equipment to the extension speaker socket. Right, here goes. Just put the squelch on. This gentleman's a radio ham acquaintance. Right, here we go. Is picture in picture on? Yes, it is. We'll start on the 3-watt scale, press transmit, and it's not doing a lot at all. So does that mean we're on low power? Yes, it does. In fact, it's doing 2.7 watts. Gives the impression of not being fiddled with, doesn't it? It's about what you'd get out of the box. 2.7 watts on channel 1. And 2.65 watts on channel 40. So back to channel 20. So we're in the centre of the band. Pop it onto low power, and it's doing 110 milliwatts. The transmit current on full power is 975 milliamps. That's a bit high for that level of power, so something's amiss. We'll look at deviation on here just for to see. Wow, it's saying 1.1. We're going to do the VCO and just want to see whether it's on frequency. 27, 7. Wow, I don't think that's going to be doable. It's so far out, I think the crystal's knackered. So, we'll test the receive under those conditions. So, we'll put 27, 7, 8. 7, 8, 7, 7, 8 into the frequency counter. So it's a fair test. And we'll look at the SINAD meter, which I'll actually turn on. Let's see where we are. Let's turn the squelch down. Well, at the moment it looks very good, but of course it could be falsely good because the detector's out or something. So it's 0.25 at the moment, which is superb. For 10 dB, 0.22. For 20 dB, 0.48. Full squelch. Is a wishy-washy 28 microvolts. And squelch sensitivity is probably going to be really, really good. So put the signal generator to standby, show the attenuator, and set the squelch on the radio. Signal generator back on, straight in at 0.3. Okay, so when we press transmit, needle moves across to 3, which about corresponds to what it's giving out, which is fair enough. On receive, I put 100 microvolts on the signal generator, and I'll tell you what, it's not far out. It's supposed to be 100 microvolts, it is 90. Meter lamp's working, the switches are working, the potentiometers are working. It doesn't have PA on this version, and the sockets are working. The internal speaker's working, so that's ticked quite a few boxes. Alright, we'll get the lid off. What I'm diving in for is two things I'm going to do straight away. One's the VCO, get that out of our hair, see whether it can be brought onto frequency, which I doubt. And I'll do the deviation so we can get the second test set behind me out of the way and switch it off. I don't know what I need to put it on tomorrow. So it's nice condition inside. Just as a precaution, spray that preset. They do play up. That's the low power preset. So you don't get the extra coil in this version. It's the lesser version of the 134, and you don't get the extra coil which you get in a base station. So it's slightly less selectivity, but it doesn't affect the receiving range whatsoever. So let's get on with the VCO. Let's get the multimeter. connect it to that strapping point there, which is an earth. That's supposed to be, that's our negative. We put the red wire to the negative like you would. We want the far side of resistor 4, which is there. We should have 4 volts, which we have. And on transmit, we should have 4 volts, which we haven't. I don't like adjusting these trimmers which have got wax in them. I tell you what we're going to do. We're going to replace that. I once had this customer have to send a set back because of that trimmer, and the fact it's got wax in, which it shouldn't have, we will replace it. So forget that. What we'll do instead, on the limited time I've got today, is I'll see whether we can get it anywhere like on frequency. So 4.05 is there, plus 2.8. Replace VCO-TX preset. It should be trimmer capacitor, shouldn't it? So get that done tomorrow. I just want to see whether it's going to go on frequency or whether we're going to start messing with crystals. Let's go back to the frequency counter. I'll turn that meter off. So can we get it anywhere near? No. No, I can't. So we've got a duff crystal situation there. Right, so what I'm going to do, we'll just put this on the other test set. We'll do the deviation. Doesn't matter whether it's on frequency or not for that. It's 1.5. So I want the feedy backy one, that's a good term, isn't it, to the centre position. I hate vertical presets. That's the central position, and then we'll do the deviation on there. On the European version of this chassis, you don't get the feedy backy one, so there you go, they've just put a fixed resistor in. Wallow, wallow. That's it, that's set. So it was 1.5 kilohertz. It's now 2.2 average to 2.5 peak, which is where we want it. Right, we'll switch that test set off. Go back to this test set. See what the deviation reads on this one, just for giggles. Might be right. Wallow. No, it's not today. Right, we'll go through transmit. I'm just feeling that. No, it's all right. I wasn't going to adjust it. The shadow from the light was such that it looked cracked. Right, here we go, transmit. So we're on the 3 watt scale. We want the centre of the peak. It's about there. I've made a slight adjustment there. Centre of the peak. Centre of the peak. And then with the correct trimming tool, does the white one fit these? Nope. Perhaps it's the blue one. Is it the blue one that isn't in my packet for some reason? Yeah, because some person who works here has left it on the bench and there's only one person works here. So temporarily we put these to maximum. So we've now gone beyond 3 watts. I say don't ever leave these at maximum. Legality aside, it will kill the radio. They give you the ability to do a little bit more power to do this tune-up procedure so that you can balance it. Right, that's now doing 4.6 watts. So clockwise with the yellow one to 4.4 and anti-clockwise with the green one. They say for 3.8 watts in the manual, but you're allowed 4, so we're jolly well having 4. So that's now set. So what have we got on channel 40? We've got 4 watts. What have we got on channel 1? We've got 4 watts. That is absolutely perfect balance. I like it to be within 0.1. So in this case it's perfect. The radio is, when we go back to channel 20, we are on that. He's now doing 1.23 amps. And we can now adjust low power. Go back to the low scale. Of course I've waggled that and it's now not reading anything. 400 milliwatts. So let's do the receiver. And I need to put the signal generator back on whatever frequency we're on. So go back to the frequency counter. Hello, go back to the frequency counter. Thank you. 78937. 27 789 37. So you can do all these tuning things even though the thing's not on frequency, because you just set the signal generator to what is on frequency, what the radio thinks is on frequency. Alright, we've got a waveform on the signal generator, from the signal generator on the oscilloscope. A bit more volume on for a meaningful trace. I think we'll put that trimming tool back, the blue one, because numpties leave them out, don't they? And let's do the detector. Tell you what, that looks like it was spot on. So drop the signal now. Turn the oscilloscope off. Drop the signal to. We've got about 6 dB on the SINAD meter. So you're always keeping your signal generator at minimum you can work with. Start with the front end. Wow. That's made a difference, folks. Turn the signal generator down. Next coil. No, that was spot on. Tiny little bit there. Just put a bigger signal on for the IF, the intermediate frequency. Tiny bit there. And the other one. No, that's perfect. Let's get a new reading for sensitivity, and for 12 dB we've now got 0.2. So I tell you what, I don't know how he picks these sets, but they always end up corkers when he gets them. 0.2. So it's less than 0.2, but I'm between scales, so if I go to the next scale for 10 dB, it's saying 0.2 the same. So it's just that bit I can't measure. .41. So we'll put S9 on the signal generator, 100 microvolts, and we'll do the S meter on the radio. Well, it's, you know, I'm really clutching at straws to adjust that. Am I doing something wrong there? Oh yeah, that's squelch. Tell you what, I'll soon be in a care home. There's S9. Right, we'll do the squelch. That's now 100 microvolts. So I'll show you that on the attenuator. 100 microvolts, 100 and 0. And then back to minimum squelch. Put this to standby. Park this at 0.3 of a microvolt. Put the radio on to squelch. Signal generator back on. And now got squelch sensitivity of 0.58 microvolts, which is more what you'd expect. So I've got 100 microvolts at maximum, 0.58 microvolts there. We've done that. That leaves us to do the RF meter. So press transmit, and it's banging across, so deal with that with the preset there. Remember, this only reads right into a dummy load. It can read 2, it can read banging across, and it's still going to be doing the 4 watts. So that's it, that's where we're going to leave it today. It needs a crystal changing. We're going to change that trimmer. The next day I've changed the crystal for one off a recovered chassis. I haven't checked that yet, and I've put a brand new RS, so we're as good as you can possibly get. Trim, taking out that one, put in the RS one. Right, so we want the multimeter back. We'll now try and set up the VCO. So back to Mr. Chippie's red lead. We monitor resistor 4 far side. And what I need to do is to put it into transmit. It's got 5 volts, so it needs to be 4. And hopefully it'll start transmitting, because it isn't at the moment. Oh yeah, it's beautifully smooth, that. Go to channel 1. Absolutely fine. Just check proof to you that we've got transmit, it's 2 point something, that's fine. And there we are on receive. So that's that set. So see if this crystal's any good, this I've put in, which came off a DNT. You know, I think if we've got to the stage with these having wax in, it should never ever have wax in. If they've got wax in and the VCO's out, then it's time to change the trimmer capacitor. Right, let's see where we are frequency wise. We're showing the frequency counter on 27 79125. Are we anywhere near? No. It's another duff crystal, isn't it? Yeah. So I've got this dilemma of crystals, haven't I? Right, well, I'll be with you when I find one that actually works. Okay, we'll try one which hopefully is a bit closer. It's off a Midland, baby Midland. Yes. Look at that. There we go. That's the end of that problem. And I've been on the phone for 10 minutes to a funeral director who wants me to do a service not at my normal church. So everything's the right temperature. So that's it, we're done. So what I'm going to do is, I'll tell you what, we'll just recheck that VCO. Back to channel 40. Receive is there, and if I can just manipulate everything together. Yeah, that's satisfactory. Good. Right, well, I'll get that put back together, and first of all I'm going to just clean the printed circuit board where I've soldered the capacitor and the crystal, and then Bob's your uncle, as they say. Okay, so we're all back together. There's some right interference on today. One Nano Roger. Oh well, we're not hearing anybody today. Anyway, that's a really nice set, so I'm pleased he's got another good one. And we'll do an on-the-air test later on, and we'll start off with our standard replacement mic, and then we'll move on to the factory original mic, which is no doubt with this. So thank you for watching Rotel RVC220. Couple of things to do there, and just to take that on board, folks, that if these are filled with wax, don't try and move them because it's going to be unreliable. Thanks for watching.